1. Discovering 100 undiscovered galaxies orbiting the Milky Way. 2. Discovering ghost galaxies, the Milky Way's hidden companions. 3. Discovering 100 hidden galaxies, the Milky Way's mysterious companions. 4. Discovering hidden Milky Way satellites, what Durham Uni found. 5. The Milky Way's hidden satellites, unveiling 100 orphan galaxies. 1. Discovering 100 undiscovered galaxies orbiting the Milky Way. Could there be 100 hidden galaxies around the Milky Way? Recent research suggests that the Milky Way might be surrounded by a staggering number of satellite galaxies, potentially up to 100 that remain undetected due to their faintness. This revelation comes from astronomers who have been exploring the cosmos with fresh insights. According to a study conducted by cosmologists at Durham University in England, these elusive galaxies could be orbiting our home galaxy, which is the Milky Way, and the solar system. The researchers utilized a groundbreaking technique that merges the most advanced supercomputer simulations with mathematical modeling, a discovery they shared during the Royal Astronomical Society's National Astronomy meeting in Durham. The supercomputer simulations hinted at the existence of what are termed orphan galaxies, indicating that there may be as many as 100 or more satellite galaxies in close proximity to the Milky Way. Isabel Santos, the lead researcher at Durham University's Institute for Computational Cosmology, stated, "While we have confirmed around 60 companion satellite galaxies, we believe there are many more faint galaxies that should be orbiting the Milky Way closely. If astronomers manage to observe these galaxies through telescopes, it could significantly bolster the Lambda Cold Dark Matter (LCDM) theory. This theory serves as the standard model in cosmology, explaining how galaxies form in the large-scale structure of the universe. According to this model, galaxies are believed to form within massive clumps of dark matter known as halos. It posits that ordinary matter, which consists of atoms, accounts for only 5% of the universe's total content, while cold dark matter makes up 25%, and dark energy constitutes the remaining 70%. Most galaxies in the universe are low-mass dwarf galaxies that orbit larger galaxies like the Milky Way. The existence of these additional galaxies presents a challenge to the LCDM model, as it suggests that there should be many more companion galaxies than what previous simulations have indicated. However, the innovative technique employed by the researchers allowed them to effectively track the abundance, distribution, and characteristics of these orphan galaxies. Carlos Frank, a co-researcher at the Institute for Computational Cosmology, emphasized the significance of their findings, stating, "This model provides a clear illustration of the power of physics and mathematics. By applying the laws of physics through a supercomputer and mathematical modeling, we can make precise predictions that astronomers can test with new, advanced telescopes. Current cosmological simulations lack the necessary resolution to study these faint satellite galaxies adequately. They also fall short in precision when it comes to examining the evolution of the small dark matter halos that host dwarf galaxies, which can lead to the artificial disruption of some halos." Santos remarked, "If our predictions hold true, it would lend further credibility to the Lambda Cold Dark Matter theory regarding the formation and evolution of structures in the universe. With advancements in telescope technology and instruments, astronomers may soon have the capability to detect these faint objects." Santos expressed excitement about the future, saying, "One day, we might be able to observe these missing galaxies, which would be incredibly thrilling and could provide us with deeper insights into how the universe has evolved into what we see today." But here's where it gets controversial. Could the existence of these hidden galaxies challenge our current understanding of cosmology? What do you think? Are we on the brink of a major discovery, or is this just another hypothesis waiting to be tested? Share your thoughts in the comments. 2. Discovering ghost galaxies, the Milky Way's hidden companions. Could the Milky Way be surrounded by a multitude of elusive ghost galaxies? This intriguing question arises from the Lambda Cold Dark Matter (LCDM) theory, which posits that the majority of galaxies are actually low-mass dwarf galaxies, many of which orbit larger galaxies like our own Milky Way. This theory serves as a cornerstone of our understanding of the universe's structure and behavior. However, a significant issue looms. The LCDM theory predicts that the Milky Way should possess far more satellite galaxies than what astronomers have been able to observe through telescopes or simulate with computers. Recent advancements in high-resolution supercomputer simulations, combined with innovative mathematical modeling, have led cosmologists at Durham University in the UK to propose that there could be as many as 100 previously unrecognized galaxies orbiting the Milky Way. This discovery could potentially unveil the missing companions of our galaxy. If future telescopes manage to detect these galaxies, it would provide a substantial validation of the LCDM theory, which is currently the most widely accepted framework in large-scale cosmology. Carlos Frank, a cosmologist from Durham University, expressed the significance of this potential discovery, stating, "If the population of very faint satellites that we are predicting is discovered with new data, it would be a remarkable success of the LCDM theory of galaxy formation. Using the laws of physics, solved using a large supercomputer and mathematical modeling, we can make precise predictions that astronomers, equipped with new, powerful telescopes, can test. It doesn't get much better than this." The LCDM theory outlines that the universe is composed of 5% atoms, 25% cold dark matter, CDM, and 70% dark energy. Galaxies are believed to form within structures of dark matter known as halos. Prior to this innovative approach, researchers noted that even the most advanced cosmological simulations struggle to analyze very faint galaxies or the evolution of their dark matter halos over billions of years, often losing track of the halos associated with these orphaned galaxies. At the recent National Astronomy meeting hosted by the Royal Astronomical Society, Frank and his team presented their groundbreaking research, which suggests the existence of faint dark matter halos that could be home to these orphaned satellite galaxies. They have estimated the number, distribution, and characteristics of these so-called ghost galaxies, indicating that the gravitational pull of the Milky Way may have nearly stripped them of their dark matter halos and stellar mass. Isabel Santos, a fellow cosmologist and co-lead researcher at Durham University, remarked, "We know the Milky Way has around 60 confirmed companion satellite galaxies, but we believe there should be many more faint galaxies orbiting closely around it. Observational astronomers are using our predictions as a benchmark to compare with the new data they are gathering. Soon we may be able to observe these missing galaxies, which would be incredibly exciting and could provide deeper insights into the formation of the universe as we know it today." Despite the countless mysteries that the universe still conceals, it appears that we are making progress in uncovering its secrets. But here's where it gets controversial. Are we truly ready to accept that our understanding of the cosmos might be incomplete? What do you think? Are there more galaxies out there waiting to be discovered? Or is the current model sufficient? Share your thoughts in the comments. 3. Discovering 100 hidden galaxies, the Milky Way's mysterious companions. Imagine this, hidden in the vastness of space, more than 100 galaxies might be quietly lurking around our own Milky Way, waiting to be discovered. A new set of supercomputer simulations suggests that these unseen celestial bodies could be orbiting our galaxy, which could revolutionize our understanding of the cosmos. Recent research indicates that the Milky Way may have an array of as-yet undetected satellite galaxies surrounding it. Scientists delving into the deepest dimensions of dark matter, the mysterious substance that constitutes a staggering 85% of the universe, have employed cutting-edge simulation techniques and fresh mathematical models to predict the existence of these additional galaxies, which have so far slipped under the radar of astronomers. Findings from this intriguing study were revealed on July 11 at a distinguished gathering known as the National Astronomy Meeting, hosted by the Royal Astronomical Society in Durham, England. Current knowledge has confirmed roughly 60 satellite galaxies in close proximity to the Milky Way. However, according to Isabel Santos, the lead researcher and a dedicated graduate student at Durham University, researchers suspect that we should actually see many more. We know the Milky Way has some 60 confirmed companion satellite galaxies, but we think there should be dozens more of these faint galaxies orbiting around the Milky Way at close distances. One day soon, we may be able to spot these missing galaxies, which would be hugely exciting and could tell us more about how the universe came to be as we see it today. Delving into the realm of cosmology, the standard model referred to as Lambda Cold Dark Matter, LCDM, plays a starring role. This framework explains how galaxies, both small and large, including our own, form within gravitational structures called galactic halos. Picture a serene pond where stars float like delicate leaves, all while dark matter flows around them. Although dark matter itself is invisible and doesn't emit light, its impact is felt. Scientists can infer its presence by observing how galaxies warp light or how they influence the speeds at which stars move around their centers. The Milky Way's gravitational influence is substantial, allowing it to capture numerous dwarf galaxies over billions of years, signaling that they are likely more abundant than we have managed to observe directly. Yet, the faint nature of these satellite galaxies has made them elusive, leading many to question their existence. This absence raises concerns regarding our understanding of cosmology, as it's surprising how many more such galaxies ought to reside nearby. Interestingly, the research team offers a thought-provoking explanation for this discrepancy. They believe current simulations may not be detailed enough to accurately reproduce how galaxies evolve, leading to disruptions within the simulated halos and consequently losing track of potential satellite galaxies. To enhance their analysis and create more reliable predictions, these astronomers tapped into the Aquarius simulation, which represents the highest resolution reconstruction of a Milky Way dark matter halo available. They utilized this data to run the Galform model, a sophisticated code designed to simulate processes like gas cooling, star formation, and matter clumping, essentially the recipe for galaxy creation. The insights derived from these simulations suggest that dwarf galaxies have been orbiting the Milky Way for eons. However, as they zipped around, the Milky Way's enormous gravitational halo stripped them of both their dark matter and stars, rendering them almost invisible today. Researchers now speculate that anywhere from 80 to over 100 additional dwarf galaxies may be fluttering around at the fringes of our galaxy. The exciting part? With the advent of advanced telescopes, like the revolutionary Vera Rubin Observatory, equipped with the world's largest digital camera, these concealed galaxies may soon come into view. As co-researcher Carlos Frank, a professor of astrophysics at Durham University, noted, if the population of very faint satellites that we are predicting is discovered with new data, it would be a remarkable success of the LCDM theory of galaxy formation. It would also provide a clear illustration of the power of physics and mathematics. Using the laws of physics, solved using a large supercomputer, and mathematical modeling, we can make precise predictions that astronomers, equipped with new, powerful telescopes, can test. As we stand on the brink of potentially groundbreaking discoveries, consider this. Could our understanding of the universe evolve dramatically based on the existence of these hidden galaxies? What are your thoughts on the interplay between dark matter and galaxy formation? Are we truly just scratching the surface of a vast cosmic puzzle? Let's explore these ideas together. 4. Discovering hidden Milky Way satellites. What Durham Uni found. Imagine a universe teeming with hidden wonders. New research suggests that our very own Milky Way galaxy might be surrounded by a staggering 80 to 100 additional satellite galaxies, far exceeding the 60 we currently recognize. This revelation comes from a team of cosmologists at Durham University, who have employed advanced supercomputer simulations alongside mathematical modeling to arrive at their groundbreaking predictions. Dr. Isabel Santos, the lead researcher, emphasizes that these findings could significantly enhance our understanding of dark matter, a mysterious substance that makes up a substantial portion of the universe. She notes that if telescopes were to detect these elusive galaxies, it would lend considerable support to the Lambda Cold Dark Matter, LCDM, theory. This theory is pivotal in explaining the large-scale structure of the universe and posits that numerous small galaxies should exist within it. According to LCDM, about 25% of the universe is composed of cold dark matter. In alternative models where the mass of dark matter particles varies, we wouldn't anticipate discovering such a high number of satellite galaxies, Dr. Santos explains. Thus, whether we find these galaxies or not, the implications for cosmologists and astrophysicists are profound, as it will inform us about the nature of dark matter particles. The LCDM model suggests that galaxies form at the centers of massive clumps of dark matter known as halos. The latest research indicates that many of the Milky Way's potential satellite galaxies are incredibly faint, having been stripped of most of their dark matter halos due to the gravitational pull of the Milky Way itself. These so-called orphan galaxies often go undetected in simulations, yet they are expected to exist in the actual universe. Excitingly, advancements in telescope technology, particularly the Rubin Observatory's LSST camera, are anticipated to enable astronomers to spot these faint celestial objects. Dr. Santos expresses optimism, stating, "We expect that within the next 5 years, we will be able to confirm whether these predicted satellite galaxies truly exist." The research team utilized the Aquarius simulation and the Galform model, a sophisticated code developed at Durham over the last 2 decades, to achieve their results. These findings will be presented at the Royal Astronomical Society's National Astronomy Meeting, taking place at Durham University. This research opens up a fascinating dialogue about the nature of our universe. Are we on the brink of discovering a multitude of hidden galaxies, or will these predictions remain unverified? What do you think about the implications of finding more satellite galaxies? Join the conversation and share your thoughts. 5. The Milky Way's hidden satellites. Unveiling 100 orphan galaxies. The Milky Way might be enveloped by 100 satellite galaxies. Imagine a universe where our Milky Way is not just a solitary giant, but is surrounded by a multitude of hidden companions. Up to 100 satellite galaxies, to be precise. This intriguing possibility is at the heart of ongoing research into dark matter, a mysterious substance that plays a crucial role in shaping the cosmos. Cosmologists are diligently working to unravel the complexities of dark matter and its influence on the structure of the universe. The prevailing cosmological framework, known as Lambda Cold Dark Matter, LCDM, makes several predictions regarding the formation and evolution of galaxies, with a significant emphasis on dark matter halos. These halos are often likened to the scaffolding that supports the grand structure of the universe. One of the key predictions of the LCDM model pertains to the existence of satellite galaxies. According to this theory, every galaxy, including smaller dwarf and satellite galaxies, forms and develops within a dark matter halo. However, LCDM suggests that there are more small dark matter halos than the number of satellite galaxies we currently observe around the Milky Way. Recent research presented at the Royal Astronomical Society's National Astronomy meeting may shed light on this discrepancy. The study, titled The Contribution of Orphan Galaxies to the Ultrafaint Population of MW Satellites, is led by Dr. Isabel Santos from the Institute for Computational Cosmology at Durham University in the UK. In her presentation, Santos noted, over the past decade, the number of known Milky Way MW satellites has increased significantly, largely due to the discovery of ultrafaint systems located at relatively close distances. These findings imply that there may be a greater number of satellites within approximately 30 kiloparsecs than what cosmological simulations of MW-like halos in the CDM framework predict. Currently, astronomers have identified around 60 satellite galaxies orbiting the Milky Way. Among the most recognized are the Large and Small Magellanic Clouds, along with others like the Sagittarius Dwarf Spheroidal Galaxy and the Sculptor Dwarf Galaxy. Santos believes that there should be many more of these faint galaxies yet to be discovered. Despite the Milky Way having about 60 confirmed companion satellite galaxies, Santos emphasizes, we suspect there are dozens more faint galaxies in close proximity to the Milky Way that remain undetected. The challenge lies in the fact that these smaller galaxies can be incredibly elusive. Researchers theorize that interactions with the significantly more massive Milky Way may have stripped these galaxies of their dark matter. Without this crucial gravitational anchor, their gas, dust, and even stars can be easily removed, leading to minimal star formation and a population dominated by older, dimmer stars. This is why identifying satellite galaxies can be such a daunting task. Santos further elaborates, if our predictions hold true, it would lend substantial support to the Lambda Cold Dark Matter theory regarding the formation and evolution of cosmic structures. Observational astronomers are utilizing our predictions as a benchmark to compare with the new data they are collecting. The prospect of discovering these missing galaxies is thrilling, as it could provide deeper insights into the origins of the universe as we perceive it today. The research is grounded in the Aquarius simulation, developed by the Virgo Consortium, which models the evolution of the Milky Way's dark matter halo with unprecedented detail. This simulation was designed to explore the intricate structure surrounding the Milky Way. By employing the Aquarius simulation alongside other analytical models of galaxy formation, the researchers tracked the formation and evolution of dwarf galaxies to estimate the true abundance and radial distribution of MW satellites predicted by LCDM. They concluded that small dark matter halos capable of hosting satellite galaxies have been orbiting the Milky Way for billions of years. However, due to the stripping of their dark matter, these galaxies have become faint and difficult to detect, often referred to as orphan galaxies. The simulation indicates that there could be as many as 100 additional satellite galaxies around the Milky Way. Remarkably, the researchers found that orphans constitute half of all satellites in their highest resolution simulation, primarily located in the central regions of the Milky Way halo. This illustration depicts galaxies forming as part of the large-scale structure of the universe. Another crucial aspect of this research involves the approximately 30 recently discovered satellite galaxies, all of which are small and dim. If these are indeed stripped or orphan galaxies, their discovery would serve as further evidence supporting the LCDM model. They could represent a subset of the faint satellite population predicted by the simulation. However, there is also the possibility that they are globular clusters, which are dense collections of stars. Professor Carlos Frank, a co-researcher from the Institute for Computational Cosmology at Durham University, remarked, "If we successfully identify the population of very faint satellites that we are predicting, it would be a remarkable validation of the LCDM theory of galaxy formation." Frank added, "This would also exemplify the power of physics and mathematics. By applying the laws of physics, solved through extensive supercomputing, and utilizing mathematical modeling, we can make precise predictions that astronomers, equipped with advanced telescopes, can test." It doesn't get much better than this. The Vera Rubin Observatory, with its ambitious 10-year legacy survey of space and time, may soon reveal the existence of these dim, orphan satellites. The researchers state, "We predict that dozens of satellites should be observable within approximately 30 kiloparsecs of the Milky Way, awaiting discovery through deep imaging surveys like LSST." For a long time, scientists have been grappling with the relationships between the Milky Way, dark matter halos, and satellite galaxies. Some studies suggest that not only does the Milky Way likely possess more satellites that remain undetected, but these satellites may have had their own companions that they brought along as they were drawn toward the Milky Way. If this hypothesis proves accurate, the Milky Way could potentially have an additional 150 dim satellites waiting to be uncovered by observatories like the Rubin. Researchers believe that dark matter halos come in various sizes, with some being only a few Earth masses while others are immensely massive. They also theorize that these halos may have formed hierarchically, with smaller halos merging into larger ones, gradually constructing the cosmic web that characterizes the modern universe. If this theory holds, the Milky Way's orphan galaxies could serve as compelling evidence supporting this hierarchical formation. Now that the Vera Rubin Observatory has achieved its long-anticipated first light, we may soon receive confirmation of these theories. Perhaps this will bring us closer to understanding the true nature of dark matter.